it down, but then after that, to cover your gluteus maximuses, photograph it, right? Once we're done. Now you have a way of saying, but John, look it, they're right there. That's your writing. You said this. You go, oh crap, you're right. I give you a half point back, right, or a point back. So the first thing is, this is going to be worth 8 points in your exam. You only have now 92 points to worry about. Okay? And I'm going to be very particular. I'm going to be very fussy. I'm going to show you what you can and can't do to get those 8 points. The first thing is, get the idea of your hypothalamic pituitary portal system. We're going to draw a little pituitary hypothalamus idea. That's what this is supposed to be. I know that there are these cells called neuroendocrine cells that are in my hypothalamus. And until I get really good at this, I'm going to label that neuroendocrine. So I'm going to write down neuroendocrine and point to it. Now remember, it's a neuron that releases hormones. So maybe help you put some little dendrites on it. Just to reiterate that fact. Put some cells down here for the anterior pituitary. And then, if you remember, when we talked about how the hypothalamus controls the release of hormones, and we had this portal system that came from the hypothalamus and went all the way down to the anterior pituitary. We're going to represent that by doing this. That's my portal system. It's my capillary bed. It comes all the way down in here. You're going to label it. All right? You're going to call it the hypothalamic pituitary portal system. Do not abbreviate it as HPPS on the exam. It will take a point off because I don't know what that means. Keep in mind that when you guys write answers out, really you're trying to teach somebody who knows nothing about it, about the topic. So pretend I'm totally stupid or ignorant of this information. Now, we also have a target for this whole system. So we're going to draw a target down here. Target organ. This is a non-specific pathway for a moment. You can call it an organ, you can call it tissue, I don't care which. Now, in terms of a basic template for how this works, from this neuroendocrine cell located in the hypothalamus that ends in what's called the median eminence, actually, it's going to produce a hormone known as an RH. Well, that's the abbreviation for either the releasing hormone, bless you, some call it a regulatory hormone, but RH stands for releasing hormone. It's just the type of a hormone that it is. It's not the actual name of a specific hormone. And that hormone is going to travel through my hypothalamic pituitary portal system, and it's going to get to a cell located in my anterior pituitary. I don't care which of those 4 boxes you take it to. But then in response to that, the cells of the anterior are going to release their type of a hormone in response to the releasing hormone, and they're going to release what's known as an SH, which stands for stimulating hormone. Now, take a moment and think about where we're finding this releasing hormone. It's only traveling through this portal system. It came from up here and it's going to go down into here. But this this stimulating hormone is found in your general circulation. That means I can take a blood sample from your big toe, from your knee, from your nose, your elbow, and I'll find this hormone maybe in that sample. It can be anywhere in your body. So for the moment to drum this in, maybe put down in general circulation, so you know where you're going to find your stimulating hormones. Now, since that's in general circulation, right, that is the definition of a hormone, right? Or a chemical signal traveling through the circulatory system. It'll get to a receptor located on your target organ. So I'm going to kind of cut through my word here, and I'm going to bring the SH to go right to my receptor. And when the SH lands on the receptor located on the target organ, then that's going to cause the target organ to produce a hormone, perhaps, in response. And this is the hormone that we're looking for in your blood. And then we're going to pause, because this is a non-specific pathway. I look at this and I realize that a releasing hormone is triggering the release of a stimulating hormone, and the stimulating hormone is triggering the release of a hormone. Does that sound familiar? Yeah, it sounds like the type of stimulus that triggers the release of a hormone. The very first one called hormone to hormone. That's what this is, a relay system. That hormone triggered that hormone. That hormone triggered this hormone. Now, the way I've drawn it this way, if you were to leave it just like this, what you're telling me is you went into my bathroom, you turned on my bathroom faucet, and you walked away. Right? It's going to just keep running and running and running and running. I need to control the level of hormone. This is where your negative feedback pathway comes in. To make sure that we don't over or underproduce this, we're going to show the effect of a negative feedback coming from this hormone targeting two things. Number one is going to target the neuroendocrine cell that is releasing my releasing hormone. And then you want to pay attention to the images, to the symbols. That is an arrow. That is an arrow. That is an arrow. That is not an arrow. Right? That's a timeout like in sports. Hey, wait, stop. Which is what it means. It's saying decrease the level of your releasing hormone. Now, when you guys start working through the rest of 242, you guys got a good example of this tonight. 242 is different than 241. In 241, I had to worry about memorizing lots of bone parts. I can hold those damn things in my hand. I can see a trochanter, an olecranon process. I cannot see adenylate cyclase or cyclic AMP. It's more intellectual, it's more abstract. And that's where the difficulty gets transitioned from. Not so many things to memorize in terms of touch, but more of intellectual procedures and processes. Physiology is about how A will cause B. But then B could cause C, and C could cause D, and on and on and on. So if I focus on what happens if I don't have C, I can realize how this could work, but then everything downstream gets screwed up. So what's going to happen if I have less releasing hormone? What am I going to have less of as a consequence of that? Less stimulating, right? If I have less stimulating, what will I have less of as a consequence of that? Less of the hormones, okay? Now here's where this becomes a cyclic pattern. Not only will this hormone do a negative feedback on the cells that produce the releasing hormone, it also does a negative feedback on the cells that release the stimulating hormone. I get a real strong signal then saying, hey, let's not make lots of this hormone as a final consequence. Now, this black symbol here is called negative feedback. The important thing to keep in mind about negative feedback is it's not an on-off switch. It's a dimmer light. It's a volume control. So, as the level of hormone increases, the strength of the negative feedback increases. Right? As the hormone level increases, the strength of negative feedback increases. It's like putting on the brakes even harder and harder. What's going to happen to the negative feedback signal if the hormone level drops? The negative feedback signal gets weaker. What does that do then to the level of RH? It's going to go back up again, right? Because we're removing the brakes off its production. More of this means more of that. More of this means more of that. And what we're going to see as we go through the rest of this week is that your blood levels are never constant. They're not static. It's like a roller coaster, where if I were to plot, if this is your average level of a hormone, it's going to kind of look like this throughout the day perhaps. As I start producing too much, my negative feedback increases, and I stop making it. That allows the blood levels to slowly go back down. But now I've got too little of the hormone. I reduce the negative feedback, which allows the hormone levels to go back up. And this is going to happen depending upon what kind of a hormone we're talking about. Some of your hormones last for seconds, some for days. They will be metabolized by your liver. It's going to be broken down. So we're going to run out of this hormone. So I always have to have a variable amount of production. And that's determined by our negative feedback pathway. Now you know some things about this, or at least I'm going to want you to know some things implicitly about this. If I am talking about some kind of a stimulating hormone, like the kind that we just mentioned in the last bit of tonight's lecture, which I know you guys are tired, we talked about what's called FSH, right? The follicle stimulating hormone. Right there I know several things based upon its name. I know where it comes from. It came from the anti-pituitary. I also know that some kind of releasing hormone had to trigger its production, because that's the pathway of this system. And I know that it's going to have a target somewhere in the body, and it'll be under the influence of a negative feedback system. I know all those things because it is a stimulating hormone. I know the same thing for a releasing hormone. Its job is to trigger a stimulating hormone, whose job it is to trigger some kind of a hormone, who is also under the influence of a negative feedback, but it also came from a neuroendocrine cell found in my hypothalamus. I know all these things. This will help me problem solve when I'm looking at a consequence of maybe this happening or maybe this not happening. Now, I didn't name any hormones to this. Now we're going to do it again. But now we're going to be very specific and actually name hormones so you can see how the names help you to know where the heck they come from and what they do. So we're going to do it all over again. It's also good practice. We're going to do another hypothalamus pituitary portal system. You're going to draw another neuroendocrine cell, because the more you do it, the more you learn it. The more you learn it, the better you remember it. There you go, endocrine. Give it some dendrites perhaps, just so I know that it's a neuron. Give me some cells of my anti-pituitary. Just help me keep track of what it is I'm looking at. Now, when you do this on the exam, you have to label everything. You're going to label the neuroendocrine cell. You're going to label the hypothalamus pituitary portal system. I'm not going to label the portal system here just to minimize and make the diagram cleaner, a little bit neater. But every time you do this, you will always name it on the exam. So there is my portal system. I'm going to show my releasing hormone coming from my neuroendocrine cell. We're actually going to name it now. We're going to call it TRH. Now, on the exam, you're more than welcome to abbreviate. You're going to use the word TRH. But also know what it stands for, because later on I may say, what does TRH stand for? Right? And that is going to be, oops, thyrotropin releasing hormone, right? TRH. I'm going to show it traveling through the portal system, getting to the cells of the anterior pituitary. So there is traveling through it. I don't care which of these cells you have it go on to. And I know from the template idea that it's going to cause the release of some kind of a stimulating hormone. Well, in this case, it's going to cause the release of what's called TSH. And TSH is for your thyrotropic. Ics are down here, ins are up there. Thyrotropic stimulating I'm getting in the way of my negative feedback. Okay. Hormone. I should not have put this here. Oh well. I know that goes into general circulation. It's going to go to some kind of target, right? And it's going to go to your thyroid gland. That's going to be the target thing we just ended up talking about tonight in the lecture. I'm going to show a receptor just so I can keep in mind the idea that hormones have receptors. TSH is going to go here. And to show my negative feedback, I'm going to draw it this way. From this, we'll do it up here. Right? We're going to release T3 and T4. Those are the two hormones I can get in response to TSH landing on the cells of my thyroid gland. Now we're going to show them as a group. Both of these hormones, right, will do negative feedback on the release of TSH and on my neuroendocrine cell for the release of TRH. So I can control the level of T3 and T4.
Is the negative feedback always happening like simultaneously with the neuroendocrine cell and?
Yep, because remember, it's in your blood, and your blood will travel through both parts of your brain.
Yes.
Yep.
Okay.
All right, that's 8 points. It'll take you about a minute and a half to do. You only have 92 points to worry about.
Do you want us to draw the general one or the specific one?
Well, you can be drawing specific ones.
Okay.
I'm going to tell you, ask me to draw me the regulatory pathway for T3 or for cortisol or for this or for that.
Okay.
All right? You must always label, even though I did not do it, because we're trying to keep our diagram somewhat clean in this scenario. You must always label the pituitary portal system.
In the diagram you drew in the lecture, you started from, or that was on the slide, you started from the state variable in the body, you know, whatever the level of whatever, that you know, the osmolarity.
Increased plasma osmolarity,
Right.
being dehydrated.
So do we need to be able to say, well, what's the body thing that the thyroid?
Nope, not for this, right? We're simply just showing the regulatory pathway, and the regulatory pathway is this negative feedback that influences the releasing or stimulating hormones that overall lead to the actual level of hormone itself.
Is that because in this case there isn't some measured state in the body that you're turning thyroid up and down for?
Yeah,
It kind of wants to
because
be
the hormone is the state.
Okay, so if there were like blood pressure or something in the loop, then we would want to.
You would stick that in there too, yes,
Okay, got it.
right?
Thank you.
But we actually don't have that for any one of these, thank goodness for this.
Even better.
Okay. Now, here's my suggestion. You've learned this, let's say tomorrow, you're hot, you're cranky, take a long hot shower, you got steam all over the bathroom mirror, before you even get dressed, right in the steam, this pathway. Okay, practice it, all right? It is gonna be on your test, all right? Now, speaking to that, let's say this is your sheet of paper on the exam. And here's the question, right? There's all the words to the question. Those of you that already had me before realize they tend to give you just enough space to actually write the answer, so you already have an idea of how much you need to say. If I give you a 1-inch piece of white blank paper, don't write me a novella, because it won't fit in the 1 inch. So if I give you half a page to draw this mechanism, in terms of scale, do not make this your diagram. Oh, some of you will try. All right? And I'm thinking, oh, you're going to go to jewelry school and be a jeweler. Right? Because then the last little part, this part of the question that's in blue, will say, do not make this difficult to read. Do not make it so small that when it's at 3 a.m. my eyes are tired and trying to read it, because I will not grade it. You get 0. Okay? I'm giving you lots of space. Take advantage of it. Right? You practice it, within a minute, you've cranked this out. You've got 8 points. Right? Now, there's one other version of this for tonight we need to look at. An example of how sometimes the hormone names do not help you. So we do another hypothalamic pituitary system. So you're getting really good at this already. You can already figure out what it's going to look like. Neuroendocrine cell, cells of the anterior pituitary. I must show my hypothalamic pituitary portal system. So I'm going to show that capillary system traveling down the infundibulum to the interpituitary. I'm going to show the target, but now the target is going to be the adrenal gland. So there's my adrenal gland, the two parts of it that we'll learn in lecture on Wednesday. I'm going to label it adrenal gland, so I know what the hell it is that I'm looking at, or at least so John knows what he's looking at. I'm going to label this part the cortex. I do not need to label that the medulla because it's not a part of our conversation. I know the hormone that comes from the neuroendocrine cell that's involved in this pathway. It's called CRH. That's nice. It's an RH. I know that it came from a neuroendocrine cell. I know it has to travel through my pituitary portal system to get to the cells of the interpituitary. And what does it stand for? And that is corticotropin. Corticotropin. Releasing or regulatory hormone. And that's going to get to the cells of the interpituitary and trigger the release of a stimulating hormone, but I would not know that if I saw the name. I have no idea what the hell this is if I wasn't taught what it is. It's known as ACTH. I can spell ACTH, which is one of the advantages of using abbreviations. What does ACTH stand for? Adrenocorticotropic hormone. That's a mouthful. I've only got 4 letters to play with when I abbreviate it. Right? And this is also, don't forget, listed in your textbook if you're trying to remember how to spell these things. Now, I know ACTH is a stimulating hormone. I know stimulating hormones are in general circulation until they find the appropriate target cell that has the appropriate receptor. I need to convey that with my diagram. So here's where you can lose a point. You do this. That to me says that maybe ACTH goes to the entire adrenal gland, right? That's not accurate. So don't do that. You need to show that it's going to go to the cortex. That's where it goes. And then in response to that, the cortex will produce cortisol. Now, where else can you guys screw up where you have screwed up in the past? If you do this, because you're just being quick, you're not being careful, you do this. That looks like you're pointing to the medulla. That's going to cost you a point. All right? I'm going to read your exam answers and look at your diagrams as if I know nothing about this stuff. You're teaching me through your answers and through your diagrams. The devil is in the details. All right? One of the things that maybe I think really helped me with this and in organic chemistry is that my dad made me take 2 classes of mechanical drawing in junior high school. All right, T-squared, and I learned to be precise with my overhead, my lateral view, and all my other angles. So you got to really be careful as how we're drawing this. That's sloppy. Don't do it. All right, just have it go right to the cortex. It's simple. You can't misunderstand it. No worries. Are we done?
Yep.
No.
What are we missing?
Negative.
Negative feedback to where? Both the releasing right and the pituitary. So we show the negative feedbacks coming up here and coming up here. And then I'm done. Keep in mind that the feedback is a volume control issue. What you guys want to work on is that as the level of hormone increases, the strength of the negative feedback also increases. And if the negative feedback increases, these guys decrease. And that's what you want. You're basically telling the adrenal gland, hey, dude, quit making cortisol for God's sakes. And over time, the cortisol levels will begin to drop, the negative feedback drops, and then we begin to have some permission to produce more of the CRH and permission to produce more of the ACTH, and we start making more cortisol. It's a roller coaster. Keep in mind then that when our blood levels of various chemical substances, it's not a steady level like this, right? It goes too much, not enough, too much, not enough, and the average is our physiological homeostasis. Practice this, be really good at it, because on Wednesday, I have time to do yet another little discussion of a seminar. How many of you ever heard of Cushing's disease? How about Addison's? All right, you got Cushing's syndrome, Cushing's disease, primary and secondary Addison's, otherwise known as adrenal insufficiencies. We're going to show the regulatory pathway for all four, so you can see how one hormone can cause 4 different symptoms. And you can tell which disorder it is based on a combination of, do I have more or less of this in conjunction with more or less of these? And that's how you can differentiate primary from secondary Addison's, Cushing's syndrome from Cushing's disease. It will be very easy, all right? It's going to be very easy because, first of all, you'll be knowing how to do this. If you don't know how to do this, then you're going to feel a little more overwhelmed on Wednesday when I show you 4 different versions of this. You guys have any questions? Oh, go ahead.
The adrenocorticotropic hormone, is that there's no receptor I'm noticing on?
Oh, I just got lazy.
Oh, okay.
Yeah, so no, that's good. All right. We'll just put a little. There you go.
If that goes directly to the inside, does that mean that it's a lipid hormone?
Yes and no. See how profuse the capillaries go in? So right now, when we talk about tonight, we're going to be looking at the 3 different levels of the cortex. We're going to be looking at the zona glomerulosa, the zona fasciculata, and the reticularis. In lecture, we're going to talk about what each hormone comes from each of those 3 layers. Right? Cortisol is going to come from the fasciculata, the middle layer of that. And it's usually, if I remember right, I got to check this, that's a water soluble because it's going through the capillary system and allowing on a membrane bound receptor and go through a cyclic AMP pathway.
That's this one on the end?
Yeah.
Okay.
Yeah. Right.
The diagram just looked different.
So for the purpose of actually just getting those 8 points, to be able to do this, and the nitty gritty of how it gets to it, to whatever degree we talk about it on Wednesday lecture, you'll need to know. But I'm not going to ask you if it's going to be binding, if it's lipid soluble, or I'm not going to ask you that.
Right, but the other 2, they looks like they are on receptors on the outside of the target organ.
True. Yeah.
But on the adrenal, it actually permeates into. It's on the
Yeah,
outside
but
as well.
there'll also be receptors on those cells. So what I'm trying to get to is, don't worry about whether or not these examples, if they're hydrophobic or hydrophilic, but know the terms in your mind. So if someone in the future says, here's a list of hydrophobic hormones, you know what that is telling you all about.
Okay.
I'm not going to hold you accountable for these guys.
Okay.
But when you
Okay.
choose the receptor on the outside, that's just for cartoon purposes.
That's just for cartoon purposes to let you realize that all hormones need a receptor of some kind. They simply just can't walk by us and go, hi,
Okay.
make hormone, dude.
So if we drew the 3rd one, the same way as the other.
That's fine.
Yeah.
Yep, that's fine.
And I'm assuming we're needing to do both, correct? Like the thyroid gland and adrenal gland, just like that diagram?
Do all 3.
Okay, cool.
What if I actually show you just a general concept of regulation of hormones?
Okay,
Yeah.
alright.
But I would, yeah, one of those 3 will definitely be worth 8 points on your
Okay,
exam.
okay.
Okay? All right, now, photograph this. You got 30 seconds.